Hello everyone, here is a video on the final exam review for our spring semester. So I'm going to walk through that and see how much time it takes me, and I might do that on over two videos or one. I'm not quite sure. It all depends how long they are going to be, because I don't want the upload time to take 2 hours, so we'll see. Okay, I'm going to put a timer on, a stopwatch, and check it out. All right, here we go. Give 3 Pythagorean identities. So we need to, those, there is no magic, right? You just need to know them. So the 3 Pythagorean identities. So it will be sine squared of x plus cosine squared of x equals 1. Then remember when we did the lessons, I actually showed you, and I'm going to show you one of them, not both, probably not. But then we said, okay, if we would divide through, like, let's say cosine squared, so I would divide through by a cosine squared of x, divide through by a cosine squared of x, and divide through. And when I do that, sine squared of x over cosine squared of x, well, that's a tangent, so that will give us the tangent squared of x. This here is just a 1, so plus 1. And then 1 over a cosine squared, that will be a secant squared. So that's our second identity. And then the third one is, instead of dividing through by a cosine, we will divide through by a sine. And then that will give us a 1 here. And it will be plus cotangent square of x. And that will be equal to the cosecant squared of x. Okay, so your 3 Pythagorean identities, you need to know those. True or false? Is the cosine an odd function? Well, odd functions are reciprocal over the origin. Sine functions are odd. Cosine are not. So here I'm going to show you. So is cosine an odd function? I'm going to say no. And to justify, because you need to justify, I'm going to say that the cosine function, the cosine graph looks like that, which cosine has symmetry over the y-axis and is therefore even. And another way you can show that, if you wanted to just use identities, the reciprocal identities, you could say that the cosine of a negative angle is equal to the cosine of that angle, right? So that just shows that for two opposite xy values, right? So if I pick an x right here, and the opposite x will be there. So if I have x here and negative x here, for two opposite x values, I would have the same y value, right? So that's what that means, and that will definitely be for an even function. Okay, so no, it is not even, and here is the reason why. I mean, sorry, no, it is not odd, and here is the reason why. Add and simplify. So we need a common denominator here. So I'm going to recopy it so I have a little room to work. So the denominator over here is a 1 plus cosine theta. And the other fraction has just a sine theta. So what I need, this fraction needs to be multiplied top and bottom by the denominator of that one. So I'm going to multiply by a sine top and bottom here. And then this one needs to be multiplied by 1 plus cosine. Okay, so now we're going to simplify that. Attention, attention, do remember that we don't want to simplify the denominators yet, because our hope is that something would eventually cancel with the numerator. So do not expand, like do not multiply those through, just leave them as factors like that. In the numerator, however, we have a sine times a sine, so that will be your sine squared. Plus, and so the numerator, we actually do want to do that, right? Because we want to see if something cancels eventually. with the denominator. So here we're going to have a common denominator of sine theta times 1 plus cosine theta. And your identity is still up here, right? Sine squared plus cosine squared equals 1. So we have a sine squared here and a cosine squared, so that's going to become a 1. And then we're left with 1 plus the cosine here. And sure enough, if you look at your denominator, you will notice that our denominator has that same factor here, right? So we can say, okay, those two cancel. And so our simplified answer would be 1 over a sine theta, but we never leave a sine or a cosine like that in a denominator, right? Because we know what this is equal to. So this is really going to be equal to the cosecant of theta. So the simplified answer would be cosecant theta. All right, we have to verify the identity. Now remember, verify means you're going to work with only one side of the equal, one expression, and then you have to show that it's equal to the other one, but you're not touching that other one, right? So here, again, those are your main identities, right? Tangent squared plus 1, it's right here, and it's equal to secant squared. So we're going to substitute tangent squared plus 1. We're going to substitute in the secant squared for it. Oops, I'm going to use a theta, but my problem gives me an x, so I have to respect the variable they give me for the angle, right? So let's put the x. And then a cosine squared minus, so if I rearrange this identity here, and I bring the 1 across to make it a negative, like here, right, negative, then that means I have to move the sine squared to the other side, so I'm subtracting it, so it will become negative. So that here will be equal to a negative sine squared of x. Now, those are multiplied, right, because there is a multiplication here, and I'm not touching that side. I want to see that eventually it's going to equal to that. Well, what is a sine square equal to? It is 1 over a cosine squared, right? And then this here is negative, oops, what am I doing? It's not negative 1, it's just a negative sine squared of x. And when I multiply those through, it will be negative sine squared of x over cosine squared of x, and that's equal to a sine over a cosine is a tangent, so that will be equal to negative tangent squared of x. And this is what we had, so we proved it, okay? Number 5. We need to solve this equation. So the first thing we need to notice is that we have a sine and we have a cosine, and we can't solve equations, or we can't factor like that with two different trig functions, so we're going to rewrite one of them as the other. We cannot do anything with the cosine because it's not a value squared, but we have a sine squared, so we can use our Pythagorean identity. We know sine squared is equal to 1 minus the cosine squared, right? So we know we're going to rewrite that sine square, so don't forget your 2 in the front there. And then the sine square is just going to be 1 minus a cosine squared of x. And then we have plus 3 cosine x minus 3, and that's equal to 0. And now we're going to distribute this here. So we have 2 minus, whoops, forgot my 2, didn't I? Thankful for erasable pens. 2 cosine squared of x plus 3 cosine x minus 3. And now I'm looking for like terms. So I have a 2 and I have a minus 3. So those two can be put together, right? 2 minus 3 is going to give me a negative 1. So I have negative 2 cosine squared of x plus 3 cosine x and then minus 1 equals 0. And now I'm going to factor. I don't like to have my leading term to be negative, so I could just multiply everything by a negative 1, which would make that positive, that negative, and that positive, right? And then 0 times negative 1, that's not changing, so I can leave that. And now we can factor. So let's factor. So what can I multiply here and here to give me 2 cosine squared? Well, that's 2 cosine of x and cosine x, right? And then what can I multiply to give me a 1? Well, I don't have an option. It will be a 1 and a 1. 1 times 1 is 1. Somehow I need a negative 3 in the middle, so I need a 2 times 1 will give me, I'm going to write that down here. The 2 times 1 here will give me 2 cosine x, and then the 1 times cosine will give me 1 cosine x, and when I add them, I want a negative 3 cosine x. So for me to get that negative 3, I need both of those to be negative, right? So we're going to say both of those have to be negative. So now when I multiply 2 with negative 1, I'll get my negative 2 and negative 1 here. So that will give me a negative 3. But we're not done, right? We haven't solved yet. So I'm going to come here because I'm running out of room, but separately, we have a product here, and when we multiply them, we get 0. So separately, we're going to say, okay, then 2 cosine x minus 1 equals 0. And then this one, cosine x minus 1 equals 0. And then we're going to solve that, right? So add 1 to both sides, gives you cosine x equals 1. And then where on the unit circle is your cosine x equal to 1? Cosine is your x value, and that's equal to 1 at when the angle is 0, so when x equals 0. And then isolate your cosine here, so you're adding 1 and divide by 2, so we have a cosine x is equal to 1 over 2. And then on your unit circle, cosine x is your x value. Where is your x value equal to a positive 1/2? So we want to think about that being your x value will be positive in quadrant 1 and 4, and the cosine to be 1/2 will be up here and down there, right? So that will be at pi over 3 and 5 pi over 3, right? So that will be for x equals pi over 3 and 5 pi over 3. So we have 3 answers, and we would write them here. So we would say the solution would be x equals 0, pi over 3, and 5 pi over 3. All right, so that's done. We're done with the trig. No, not quite. We have 2 more to go on the trig, and I think... No, actually, we have 2 more. We had a big trig semester, didn't we? Okay. So those formulas I will give you, and then let's look. We have find the exact value for a cosine of 75 degrees. So 75 degrees is not an angle on our unit circle, and because we don't have a calculator, we're going to have to figure out 2 angles that either add up or subtract to 75, right? You have an option. You can either add up 2 or subtract 2. So 75 degrees, we want to recall that 75 degrees is the same thing as, so what could we use? Well, we could use 45 degrees plus 30, and that would definitely give us 75, and those 2 angles are nice angles on our unit circle. So let's use that. So we're going to do an addition, right, a sum, and it's a cosine. So we're going to go to the cosine, oh no, sorry, a sum, not a subtraction. So we're going to go to the cosine, and we're going to use this identity right there, okay? So the cosine of 75 is equal to, so we're going to have a cosine of 45 degrees times this, oh sorry, cosine is cosine and cosine. Cosine of 30 degrees, and then because we're adding here and the cosine is opposite, right, we're going to subtract there, so minus a sine of 45 degrees times a sine of 30 degrees. And now let's make sure we check. So 75 we said is 45 plus 30, so we're in a cosine situation and we're having a sum of angle. So we have cosine of the first angle times cosine of the second minus sine of the first, sine of the second. So we're good to go. And now we're going to evaluate all of that using our unit circle, right? So if we recall our unit circle, cosine of 45, so 45 degrees will be right there, and the cosine will be square root of 2 over 2. The sine will be square root of 2 over 2. And then the next angle, no, sorry, that's, yes, no, sorry, I'm on the wrong thing. The next angle will be right here, that will be my 30 degree. And I don't have room, so let's move that down a bit. And that will be a square root of 3 over 2 and a 1/2. So now we just fill in the values. Remember cosine, that's your x value. So x value of 45. 45 is kind of nice because they're both the same anyway. So that will be equal to a square root of 2 over 2. Cosine of 30, so that will be square root of 3 over 2. Minus, excuse me, sine of 45, which is the y value, but still only a square root of 2 over 2, times the sine of 30, which will be a 1/2. And now when we're simplifying that, multiply those will be a square root of 6 over 4. And then minus those multiply will be square root of 2 over 4. And we can't really do anything with that. We have a common denominator, so I'm going to write it as a square root of 6 minus a square root of 2 all over 4. And that's how I'm going to leave it. Okay, and it says exact value, right? So this is an exact value, not, we didn't approximate anything. Now we're going to find the solutions for this equation here. On this equation, I worked with one of us here after school, and Florian, I think when we worked on this together, we messed up on the way we set it up, because I checked it out again here just a minute ago before I started the video. I did it on my board here behind me, and it actually worked out. So I can't remember what we did at school because I don't have my paper here home with me. But check on your paper and follow along with me and see where we messed up here, because we must have had something wrong on the setup. Okay, so here we go. Here we have a sine, a sum of angles in a sine, and a subtraction, a difference of angle in a sine. So we're going to use both of those formulas for that problem, right? So we're checking if you know all of those formulas, or at least if you know how to apply them, right? So sine of x plus pi over 4. So the sine will be sine of the first angle, so that will be x, times the cosine of the second angle, so that will be cosine of pi over 4. And then the sine will be, if it's an addition, a sum, we're going to keep the addition, right? As opposed to the cosine where we switch those. So it will be a plus. And then we're going to do the cosine of the first angle, so x, times the sine of the second angle, so pi over 4. So that's just for that portion. Now we're going to switch to this one. So I have plus. And so now we're going to do this one. So sine of the first angle, so sine of x, times cosine of the second angle, pi over 4. And now that's a subtraction, right? So we're going to do a minus here now. So minus, and then it will be the cosine of the first angle times the sine of the second angle. And all of that is equal to -1. I'm kind of running out of room, but all of that is equal to -1, right? Now let's see what happens. So we have a cosine x sine pi over 4 and a negative cosine x sine pi over 4. Those are opposite, so they go to 0, right? When we add them, they go to 0, so we can mark them off. So we're left with a sine x cosine pi over 4 and a sine x cosine pi over 4. Notice how those two are the same. So we actually have two of them. So 2 sine x cosine pi over 4. And that's equal to that -1 we had, right? And so now I'm just going to go ahead and divide by 2. And I'm going to evaluate what the cosine of pi over 4 is. Now remember, we done that earlier. But the cosine pi over 4 is right there. And the cosine will be square root of 2 over 2, right? Because it's an x value. So we're going to divide by 2. Sine of x. We're going to evaluate the cosine of pi over 4, which is square root of 2 over 2. Okay, and I divided by that 2 right there, okay? Now I want to get my sine by itself, so I'm going to multiply by the reciprocal of that. So I'm going to have sine of x equals negative 1/2, and then multiply by the reciprocal, so multiply by 2 over square root of 2. Well, those two cancel. We have a negative 1 over square root of 2, so sine of x is equal to negative 1 over square root of 2. And we're going to multiply top and bottom by a square root of 2 here, so we can rationalize this denominator. And so that's going to simplify to a sine of x is equal to negative square root of 2 over a square root of 4, which is just a 2. Now we need to get x, right? We still don't have x by itself. So we're thinking about our unit circle, and where on the unit circle, sine being your y value, is that going to be a negative? Well, the sine is negative in quadrant 3 and 4, right? Those y values. And the negative square root of 2 over 2 will be the one corresponding to the pi over 4 there, right? But in those two quadrants. So that will be where sine is equal to negative square root of 2 over 2. And that will be at, hold on, I lost it for a second, 5, sorry. This will be at x equals 5 pi over 4 for that one, right? And then 7 pi over 4 for this one. Okay, so those are the solutions for this. Okay, I think I'm going to stop this video and do a second one so that it doesn't take forever to upload. So let's see. I want to